Elevator Control Programming. Today, we will explore how programming plays a key role in controlling the operation of elevators, ensuring both efficiency and safety in modern buildings. Let's dive into the core concepts of elevator control systems and their evolution. Introduction to Elevator Control Programming. What is elevator control programming? Elevator control programming refers to the process of writing and implementing code that controls how an elevator functions. The code determines how the elevator responds to user inputs, such as button presses, and directs the movement of the elevator car between floors. It also dictates the logic behind elevator behaviors like door opening, floor selection, and emergency protocols. This type of programming is essential for ensuring that elevators operate efficiently and safely, coordinating movements to reduce waiting times and ensuring smooth operations. Types of elevator control systems. Elevator control systems have evolved over time, and different types are used based on the needs of the building. Relay-based systems. These older systems use electrical relays to manage elevator functions. Each action, like a floor request, triggers a physical relay, making the system more mechanical and less flexible. Microprocessor-based systems. These systems use microcontrollers that can handle more advanced logic than relays. This allows for faster processing, better traffic management, and improved safety protocols. Modern computer-based systems. Today's most sophisticated elevators use software algorithms and computer-based control. These systems are designed to optimize performance by adjusting elevator speeds, grouping flow requests, and even managing energy consumption efficiently. Components of elevator control programming. The process of programming elevator controls involves several key components. Motors, responsible for physically moving the elevator car. The control program manages when and how the motor activates, controlling speed and direction. Buttons. Located inside and outside the elevator, buttons allow passengers to input their floor requests, which are processed by the control system. Sensors. These detect the position of the elevator car, ensuring that the car stops accurately at each floor. Sensors also ensure doors open and close safely by detecting obstructions. Together, these components ensure that the elevator operates according to the program's instructions. Safety considerations in elevator control programming. Safety is one of the most important aspects of elevator control programming. Safety features. The code must include protocols for buttons, door sensors, and overload protection. For example, door sensors prevent the doors from closing if an object is detected, and overload sensors stop the elevator from moving if it's carrying too much weight. Adhering to safety standards. Elevator control programming must follow strict regulations set by bodies such as the Occupational Safety and Health Administration, OSHA, and other industry standards. These rules ensure that every aspect of elevator operation prioritizes passenger safety. Challenges in elevator control programming. Elevator control programming comes with several challenges. Coordination between multiple elevators. In buildings with several elevators, the system must be programmed to ensure that all elevators operate in coordination, reducing wait times and avoiding unnecessary stops at floors. Managing elevator traffic. Efficiently managing requests during peak times is complex. The program must minimize wait times, reduce energy consumption, and ensure smooth operation. Compatibility and integration. The control system must be compatible with different elevator models and integrated with the building's management system. This ensures that elevators function correctly alongside other systems like fire alarms or HVAC. Future trends in elevator control programming. The future of elevator control programming is exciting, with advancements in technology paving the way for smarter, more efficient systems. Smart elevators, powered by artificial intelligence, AI, and the Internet of Things, IoT. Smart elevators can learn and adapt based on passenger traffic patterns. This allows the system to predict high demand times and adjust operations accordingly, optimizing performance in real time. Integration with building automation. elevators will be more integrated with building automation systems, allowing greater coordination with security, HVAC, and lighting systems. Mobile app control. Future elevators may allow passengers to use mobile apps to call elevators, select floors, and even schedule elevator availability for certain times, enhancing the overall user experience. Conclusion. In conclusion, elevator control programming is essential for managing elevator operations safely and efficiently. As technology advances, elevators will continue to evolve with smarter features and greater integration into building systems. Thank you for your attention.